today's lesson, we are going to be looking at statistical measures. So these are just going to be some measures or some values or calculations that you may come across when you're looking at statistics and data management. So the first one we're going to look at is per capita. And per capita means for each head. So in statistics, when you hear the term per capita, you're thinking about the average person, or based on an average person or all average people in terms of whatever the situation may be. Usually we're looking at countries. So per capita means per the average person of that country. Net worth is the total assets or wealth minus the total liabilities or debt. So if you're looking at someone's net worth, you look at their assets, which could be things of value such as just money saved, stocks, investments, properties, even cars, things like that. So you look at their assets and then you take away or subtract their liabilities. So what are their debts? So it could be credit card bills if they owe money, could be loans, mortgages, anything where they have to pay money back or they owe money. So your net worth is that difference. So the first example we're going to look at, so many businesses, health, and economic statistics are expressed as per capita figures. In June of 2022, the national wealth of Canada was $17.6 trillion. The national debt was $1.45 trillion. The population of Canada was also 38,929,902. So we want to know what is Canada's per capita wealth. So we want to know what is Canada's wealth per person, or per the average person. So we take the wealth, the $17.6 trillion, and we divide it by the number of people. So 39,929,902. And when we divide those two, we get a per capita wealth, or an average, or the wealth per the average person of $452,094.64. So again, we're just essentially dividing two values. If we want to look at Canada's per capita debt, we do the exact same formula, except we're using the debt value, so the $1.45 trillion. Obviously, there's a few more other values there as well. 1,455,800,000,000. But realistically, once you start dealing with large numbers like that, millions really don't mean as much anymore. So we take that debt, we divide it by the population, or the number of people. So the 38 million. And in the end, we get a debt of $37,395.42. So that is the debt per capita in Canada. What is Canada's per capita net worth? Well, the net worth, remember, is the wealth, so the 17.6 trillion, minus the debt, so the 1.455 or 0.4558 trillion, all divided by, again, because it's per capita, the population. So the 38 million, or 38,929,902 to be exact. And when we do that, we get a value of $414,699.22. So that is Canada's per capita net worth. The next measure that we're going to look at is percent change. And percent change measures the value, or the change in value, over time. We do have a specific formula for that, which would be the percent change is equal to the new value minus the old value, then divided by the old value and multiplied by 100. So basically we're trying to find the percent of something. If we're figuring out what is that change, divided by the old value multiplied by 100. So the following graph shows Apple's net revenue each year from 2005 to the most recent value, which was 2021. We want to calculate the percent change from 2005, which is down here, to 2010, which is up here. So we're looking at small values, but that's really just because they're representing billions of dollars. So rather than write up those large numbers, obviously we're keeping it relatively small. So the percent change is the new value, so the 14.01 minus the old value of 1.33 divided by the old value multiplied by 100. And when we do that calculation, we find a percent change of 953,000.4%, which does make sense because it's quite a jump, right? From 1.33 billion to 14.01 billion. That's quite an increase, so that's quite a change. So it does make sense that we have a large change. And we can have more than 100% change. 100% change essentially means we double our money. We increase it by the same amount that we had. So 953.4% change is quite a bit more than doubling. For B, we're going to go through the same type of questions, just looking at different years. So here we're looking at the change from 2012 to 2013. It's going to be the same formula. Percent change is equal to our new value, so the 37.04 minus the old value, the 41.73. So even though the old value is larger, that's okay. We're going to then divide by the old value and multiply by 100. So in this case, we get a percent change of negative 11.2%. And it's okay to have a negative change. That just means that we go down, which does make sense, right? We see that we're decreasing, so we shouldn't have a positive change. We're not gaining money, we're actually losing money. So again, it's okay to have a negative percent change. Lastly, for question C, the company's financial report stated there was a 200% increase in profits from 2020 to 2021. Do you agree with this statement? Well, let's take a look. 2020 to 2021. So looking at it, you might say, oh, that's close to doubling, maybe a little bit less, so maybe they're not far off. But let's do a quick check. So percent change equals the new value, so 94.68 minus the old value, 57.41, divided by the old value, multiplied by 100, and we get 64.7%. So here we see that we don't quite have a 200% increase in profits. We actually have quite a bit less than that. We're closer to, if we had to round, we're closer to 100% increase, which again would indicate that we're doubling. So we have to kind of keep in mind that just because we see 200%, which is double 100%, doesn't necessarily mean that we are doubling our money or doubling our change. Right? So we just want to be careful of what the percent change actually refers to. The next terms we're going to look at is percentile and percentile rank. So these are kind of two terms that are kind of go hand in hand. So percentile is the value below which a percentage of the data falls. So this would be we're given a value and we want to find what percentile does it fall in. Or basically based on the data that we have, how much data fall, or what percentage of data falls below a specific value. So the formula P equals 100 times L plus 0.5E divided by N. So L refers to the number of values less than the data point. So if we're looking at all of our values and we're looking at one specific value, what is the number of values less than that. E is referring to the number of values equal to. Equal to the data point in question. So we're looking at a specific data point, a specific score. We want to find out, for E, how many values do we have that are equal to that data point. And N just refers to the total number of values, or how many data points in total do we have. Percentile rank. So percentile rank is a little bit different. This is the percent of population with a score less than a specific one. So here we would be given a percentile, and we want to figure out then what is that score that is less than that, or that is at that percentile. So P refers to our percentile. N again refers to the total number of values. So one formula we use to find what percentile a score is in, the other one we use to find what score is in a specific percentile. So let's look at one of the examples. So the table gives the mean playing times for 22 hockey players on a team. We want to determine the percentile of each score. So we want to figure out what percentage of the data is less than the time that we have, or the score. So the first one, 14.6. So we're going to use our formula, P equals 100 times L plus 0.5 E, all divided by N. So we're going to have 100 times. We're going to find that score of 14.6, which we see right here. So that score of 14.6, how many values are less than that? Well, 1, 2, 3, 4, 5, 6. There are 6 scores or times less than that. So 6 plus 0.5. Now how many scores are equal to that? Well, in this case, there's only one that's equal, the one that we have. And we're going to divide all of that by 22, which is the total number of scores. In this case, then, we should get 30. So this means the 30th percentile, or 30% of the scores are less than, or the 30% of the times are less than 14.6. You could also use kind of an indirect method and look the other way by saying that 70% of the times are greater than this person, or this time. For the second one, 21.7, so we're going to look at these scores here. So we're going to use the same formula, 100 times L plus 0.5 E, all divided by N. So 100 times, we have 17 times or scores that are less than. So 17 plus 0.5 times 2, because we have 2 scores of this, all divided by 22. And again, when we calculate this, we should get roughly 82, or the 82nd percentile. So this is saying that 82% of the data, or 82% of our times, are below 21.7 minutes, or whatever the time or score happens to be. In this next example, now we're going to try to find what time represents the 75th percentile. So we want to know, okay, what time represents the mark where 75% of the people are less than that? Well, this is where we use the other formula, R equals P divided by 100 times N plus 1. So P is 75 times 100, or divided by 100 times 22 plus 1, and we get 17.25, which we can roughly round to 17. So what that means, that doesn't mean that a time of 17 is the 75th percentile. What that means is the 17th score, or the 17th time, is our 75th percentile. So we have our list of 22. So we're going to count through and find the 17th number or time. And in this case, we find that we have a time of 20.5. So the 20.5 is the 75th percentile. For the 95th percentile, we're doing the same thing. P divided by 100 times n plus 1. So 95 divided by 100 times 22 plus 1, and we get 21.85, or you can round to 22. So 22, this puts us at the very last one. So this means that the final score of 24.3 is the 95th percentile. So 95% of the data is below that value. The next statistical measure that we're going to look at is the weighted mean. So the weighted mean is a mean in which each component has a different weighting factor. So to calculate a weighted mean, multiply each value by its weighting factor, then divide by the sum of factors. So this is technically, this formula here is essentially what we just said. So we have x bar, or the mean, is equal to the sum of, which is this sigma, just a Greek letter meaning sum of, meaning we're going to add up multiple values. So the sum of a component multiplied by its weight factor divided by the sum of the individual weight factors. So these things kind of mean the same thing. So they're both weight factors. So essentially we're taking each value, multiplying it by its weight, dividing by the total weight. So for example, a college instructor uses a weighted mean to calculate her students' marks. Jin and David's marks are shown along with the weighting, who had the better overall mark and by how much. So each student has a weight, or has a mark out of a certain part, and it has its weighting factor. So because we're looking at percentages, we need to figure out the percentages first. So if we go through, we're just going to work through Jin's first, and then I'll give you the opportunity to pause the video so that you can try and do the same calculation with David. First, though, we have to calculate the percent. So Jin had 24 out of 30. So 24 out of 30 was a mark of 80%. For the assignments, 40 out of 60, which was a 66%, or if we round it, 67%. For the test, 89 out of 120, we had 74%. 43 out of 60, 72%. 85 out of 100, 85%. And then 72 out of 90, or again, another 80%. So those are the components, and then we're going to multiply them by the specific weight factor. So we're going to have 80 multiplied by 15 plus 67 multiplied by 15 plus 74 multiplied by 25 plus 72 multiplied by 10 plus 85 multiplied by 10 plus 80 multiplied by 25. And that's all going to get divided by the sum of the weight factors, which we've highlighted, which in this case, we can put it down, but 15 plus 15 plus 25 plus 10 plus 10 plus 25. In this case, generally speaking, it should usually add up to 100, which it does in this case. So when we add that all up, let's see, so 80 times 15 plus 67 times 15 plus 74 times 25 plus 72 times 10 plus 85 times 10 plus 80 times 25. We get 77,625. The bottom works out to 100. So this works out to 76.25%. So Jin has an overall mark of 76.25. So I'm going to give you an opportunity to try to do the same thing with David. I'm going to pause the video, give you a chance to work through this on your own to try to figure out the second mark. If you're not too confident with it, or you can always just kind of wait through and skip ahead. But again, if you want to try this on your own, I would recommend you pause now. So coming back, looking at David, again, we had to find the specific percent for each section. So 18 divided by 30 gave us 60%, and so on and so on and so on. Then we took each of those percents, multiplied it by the weight factor, and then divided it by the total sum of weight factors, which was the same as the previous one, which would be 100. And we found that David had a overall mark of 74.25. So therefore, oops, a little bit too thing there. So overall, or therefore, Jin had a better mark by 2%. So again, that's how you calculate the weight or the weighted mean or a weighted average. Essentially, that's how your mark is calculated itself, because again, not everything is weighted equally. Some things are worth more, like tests are worth more than quizzes and assignments and so on. So this is essentially how your overall mark is calculated. But again, the main thing from this lesson is just looking at the different types of statistical measures that you may come across, just kind of how to calculate them if you have to, and also what they mean.